In this video, the binomial distribution is explained by calculating the probability of getting a phone number in a bar. Let's consider the following problem. Brad is a single, hot guy, and he goes every night to the local bar to meet girls. It is known that if Brad approaches a girl and asks for a phone number, the probability that she would say yes is 0.95. Another way to put it is that the probability that she would say yes is 95%. Assume that the probability doesn't change regardless of how many phone numbers Brad gets in a certain night. Yesterday Brad went out and approached 5 girls. What is the probability that he received at least 4 phone numbers? For solving this problem, we have to get acquainted with the binomial distribution. What is the binomial distribution? If we have a sequence of independent Bernoulli trials, the number of successes within this sequence has a binomial distribution. Wait, what is Bernoulli trial? Bernoulli trial is an experiment that can end up with success or failure. There is no other outcome possible except for these two. In our problem, every time Bird approaches a girl, this is a Bernoulli trial, which can end up with a success or failure. And what is the definition of success? Success is simply the event that we are counting. Note that it doesn't have to be a positive event. In our problem, success means Brad is getting a phone number. What are independent trials? By independent, we mean that the result of each trial doesn't imply anything about the future result of the other future trials. In other words, if the trials are independent, then the probability for success in every trial is the same. For example, in our problem, the probability for Brad to get a phone number is 0.95 for the first woman, 0.95 for the second woman, and so on. Recall that if we have a sequence of independent Bernoulli trials, then the number of successes within the sequence has a binomial distribution. Now, if it looks very theoretical, or maybe even scary at that point, don't worry about it. Things will get much more simple very soon when we get to practice, where we could see how it all connects. Let x be the number of successes of that sequence. This notation means that x is binomially distributed with parameters n and p. Note that this symbol, which is called tilde, just means distributed. N is the number of independent trials, in our problem 5, the 5 girls Brad approaches. P is the probability for success in every trial, in our problem 0.95. The probability of having k successes in n trials is probability of x equal k equals n choose k times p to the power of k times 1 minus p to the power of n minus k, where n choose k equals n factorial over k factorial times n minus k factorial, where n factorial is just this product, 1 times 2 times 3 times 4 times all the way to the end. For example, 3 factorial equals 1 times 2 times 3 equals 6. Note that n choose k can also be calculated by using the NCR button in the calculator. So by using this button, most calculators have it, this NCR button, we could just avoid calculating all of these factorials and we can just right away calculate n choose k. So let's come back to our problem and see how the binomial distribution can help us to solve it. What do we know? We know that the probability that Brad will get a yes is 95%. This is our P. We also know that Brad approached 5 girls, which means n equals 5. What is the assumption here? Assume that this probability does not change regardless of how many phone numbers Brad gets in a certain night. That means that the trials are independent, and every time P will be equal to 95%. So that means we can use the binomial distribution to solve the problem. And we want to calculate the probability that Brad received at least 4 phone numbers. Let x be the amounts of phone numbers Brad received. Remember that n equals 5, p equals 0.95, and we can just write it that way, which means x is binomially distributed with n equals 5 and p equals 0.95. Recall that the binomial formula is the following. Remember, we want to calculate the probability that x is greater or equal to 4. We said at least 4 phone numbers. So we have to calculate 2 different probabilities. The probability that Brad received exactly 4 phone numbers, and the probability that Brad received exactly 5 phone numbers. Let's start with probability of x equals 4. All we need to do is to plug in everything in the binomial formula over here. So as we can see, n equals 5, k in our case is 4 successes for 4 numbers, p is 0.95, remember it's p to the k, so again k is 4, k is the amount of successes. 1 minus p is 0.05, and then n minus k, all we need to do is to plug in 5 minus 4. And at that point, we can just use the calculator to take care of that, which is 5C4. Remember, use the NCR button, or calculate it with factorials, as we see here. We get 5. At that point, we don't really understand a lot. What are we doing? We just plug in the formula, right? It's good enough for getting the probability, which is 20%. The probability that x equals 4, the probability Brad will get at least 4 phone numbers is 20%. But we don't exactly understand what did we just do, like what is this formula, what is this? So in order to make it more clear, I'm going to explain it in a moment. So let's try to understand the logic behind what we just did. Why this is the right way to calculate the probability of x equals 4. Let's think about it. Let's imagine this is the first girl, this is the second one, the third, the fourth, and the fifth. And here is Brad going to approach the first lady, and he gets a no. That's too bad. However, Brad doesn't stop, and he is going to approach the second one. Wow, it's a yes. The third one, yes. The fourth, yes. And the fifth, oh yeah, he got a yes. So what are we looking at here? We are looking at a situation where we have 4 times yes. This is 4 phone numbers. This is exactly what we are looking for. So what is the probability for these 4 phone numbers? We know that probability for a yes is 95% or 95. So this is O95, this is O95, this one also is O95, and O95. O95 and means O95 times O95 times O95 times O95. This is O95 to the power of 4. It's exactly this. And the probability of a no is O05, and this is this. So you might ask yourself, so why don't we stop here? We have this. This is exactly the probability for 4 times yes and 1 time no. Let's end up with it and call it a day. Why do we need this? So we have to think about it again. This scenario shows us a scenario where we have 4 times yes, but the first girl is the one who's saying no. We could have a scenario when we have 4 times yes, but it would be the second lady who said no. So this is already a very different scenario because the first lady is different than the second lady. This table is showing us all the possible scenarios here. The first scenario is the first lady saying no, but the rest saying yes. In the second scenario, the second lady saying no, but the rest saying yes, and so on and so on. Overall, we have 5 scenarios, right? 1, 2, 3, 4, 5. Note that the probability for each scenario is exactly the same, because we already said 4 times v and 1 times x is exactly this. So overall, we have this probability here, and here, and here, and here, and here 5 times. So overall, the probability that we get 4 times yes is 5 choose 4, which is exactly 5. Now you understand what the idea behind this 5 choose 4 is exactly doing this. And we have 5 times this probability. And as we saw, overall it equals 20%. Now, I know first time looking at it might be a little bit confusing, and it's okay. I highly recommend that you will come back to this problem, try to understand, just like what we just did, try to understand the logic behind it, even if you face a different problem. Just come back to this problem, try to think hard about it, because once you get it, you understand the binomial distribution 100%, nobody can confuse you. Let's come back to our calculation. The probability that x is at least 4 equals to the probability of x equals 4 plus the probability of x equals 5. We've already found the probability of x equals 4 is 20%. We can calculate the probability of x equals 5 in the same spirit using the same formula, and we get 77%. Putting it all together, the probability that x is at least 4 equals probability of x equals 4 plus the probability of x equals 5. That means 20% plus 77%, and we end up with 97% probability. The probability that Brad received at least 4 phone numbers yesterday is 97%. And that's it. Thank you so much for listening to this lecture. Have a wonderful day.